Okay guys, today we're going to start talking about the Pythagorean theorem. The Pythagorean theorem is one of the most important theorems in all of math. So later on we're going to study some offshoots of the Pythagorean theorem such as the distance formula. The Pythagorean theorem, it's important to know that it deals only with right triangles. It does not apply to any other type of triangle other than a right triangle. Right triangles are made up of two legs. The legs are always the two sides of the triangle that make the right angle. So this would be a leg, this would be a leg. We usually call the legs of a right triangle A and B, and it doesn't matter which one is which. Then this diagonal side is called the hypotenuse. The hypotenuse is always the side directly across the right angle. It is always the longest side of any right triangle. We always call the hypotenuse C, and it's the one that it really matters if you are given side measures that you know the longest side is the hypotenuse. The Pythagorean theorem basically talks about the relationship to where if I had the legs A and B, and I took B, the length of B, and made a square with a side that size. So here I've got B by B, so I've made a square. And then I've made a square out of A, so one side is A. If I look at the area of these two squares, here I would have an area of 3 times 3, which is 9. And here I have an area of 4 times 4, which is 16. Then if I make a square out of the hypotenuse side, so now I have C times C, it's going to be 5 times 5, which is 25. If I add the area of this square and I add the area of this square, I'm always going to get the area of the hypotenuse's square. 9 plus 16 is going to give me 25. So we write the Pythagorean theorem, a squared, so this side's squared. So if I made a square here and I added it to a square made out of this side, the length of this side, I'm always going to end up with a square with a side length of C. A squared plus B squared is C squared. Always, always, always realize that C squared is the hypotenuse, and it's the one that matters. So here's some application problems of the Pythagorean theorem. So I have a right triangle, and I'm given the legs, I'm given the sides that make up the right angle. Therefore, I'm going to use A squared plus B squared equals C squared. C in this case is x, it's the hypotenuse. So 5 squared plus 3 squared is going to give me x squared. So 5 squared is 25, 3 squared is 9, that's going to give me x squared. 25 plus 9 is 34, so 34 is x squared. How do I solve for x? I will square root both sides. So the square root of 34 is x. If I was to do a decimal approximation of this, if I type this into the calculator, I get 5.8, approximately 5.8 is x. So the hypotenuse is 5.8. I can check myself because I know if this is the hypotenuse, this number has to be bigger than the other sides. 5.8 would be the longest side, so I'm pretty confident that this is the correct answer. Here we need to look and determine which sides we have. Here's my right angle. Notice I'm given the side directly across from the right angle. This is the hypotenuse. This is going to be C. So now I'm looking for one of the legs. So if I have A squared plus B squared equals C squared, let's say 10 is A, so 10 squared. X is going to be B, so I have x squared. And then C squared is 12. So 10 squared is 100 plus x squared. 12 squared is 144. To solve for x squared, I need to get x by itself. X squared is 44, and then I will do the square root of both sides. X is the square root of 44. Sometimes you may not see this as a decimal approximation. Sometimes it will be a radical in simplest form. So let's do a brief review on how to simplify any radical. So here I have the square root of 44. This is where I need to do the prime factorization. What times what will give me 44? Let's start with 2 and 22. 2 is prime, so I circle it. What will multiply to give me 22? 2 and 11. These are both prime. Any pair of numbers I can bring to the outside. So since I have a pair of 2's, I can bring 1 2 to the outside, complete my radical. What's left under the radical is 11. So x is going to be 2 square roots of 11. Here's an example of a word problem. We have a 5-meter tall ladder leaning against a wall. The base of the ladder is 2 meters from the wall. How high up the wall does the ladder reach? In this case, I'm going to draw a picture. So here's my wall, okay? And then 2 feet away from the wall is where the base of my ladder is. So my ladder is leaning here. So the ladder is the hypotenuse, because the base of the wall and this floor is going to form a right triangle. The ladder is 5 meters. I'm sorry, this is not feet, this is 2 meters. I want to know how high up the wall the ladder reaches. So I'm looking for this measurement. So I know I have the hypotenuse and I have a side. So when I plug that in, a squared plus b squared equals c squared. Let's use 2 as a, so 2 squared plus, I'm looking for my other side, x squared is equal to the hypotenuse squared. 2 squared is 4. 5 squared is 25. I subtract 4 from both sides. Then I end up with x squared is equal to 21. Then I would do the square root of both sides, and x ends up being the square root of 21. This I can't simplify because 21 is 3 times 7, both of which are prime, and I have no pairs of numbers. So I'm going to leave this as the square root of 21. I could do a decimal approximation here, and if I type this into the calculator, it would give me approximately 4.6 meters. So either of these answers is acceptable. Here we have another word problem where it's talking about a zip line. So the start of the zip line begins at the top of a 100-foot platform. The zip line will travel a horizontal distance, so that's important, of 1,200 feet. How much cable is needed to construct the zip line? So I'm going to start by drawing a picture. So here's my platform that the zip line starts from, and it's 100 feet tall. It tells me that the horizontal distance is 1,200 feet. Well, if I do the diagonal, that's not horizontal. So I'm looking here. I'm going to make a horizontal line, and that is 1,200 feet. Okay? So this is how far horizontally I'm traveling. My zip line would be constructed from the top of the platform to the end of my horizontal distance. So how much cable will I need here? Well, I'm looking for the hypotenuse of this right triangle. So I'm just plugging my values in. Let's use 100 as a squared. Let's use 1,200 as b squared. And that's going to give me c squared. In this case, I've labeled it x. So 100 squared plus 1,200 squared, if I combine those, I'm going to end up with 1,450,000 is x squared, and your calculator will do this for you. So then, solve for x, you square root both sides. Your approximation for this is approximately 1,204, so 1,204 feet would be how much cable you need to make the diagonal zip line. The last one is an example of combining Pythagorean theorem with quadratics. This is a favorite type of problem on the EOC. The hypotenuse of a right triangle, so here's my right triangle, the hypotenuse is 20 centimeters. The sum of the other two legs is 28. What is the length of each leg? Well, first I need to figure out what variables am I going to use for the legs. If I call one leg x, and I know that together they add to be 28, how am I going to write this other leg in terms of x? I can do 28 minus x, because now whatever x is, if I subtract it from 28, I'm going to get the other side because these two add to be 28. Okay? So now I have enough information to plug into the Pythagorean theorem. let's use a squared plus b squared equals c squared. Let's say a is x, b is 28 minus x. Notice that I put this in parentheses. Anytime you have more than one term for the length of a side, put that in parentheses, because this means I'm not just squaring x, I'm not just squaring 28, I'm squaring 28 minus x as a whole. And that's going to equal my hypotenuse 20 squared. So let's simplify what we can. X squared plus. Anytime I see a binomial squared, I'm not just distributing this square, it means I need to multiply this by itself again. So I'm going to use box. I'm going to have 28 minus x. I'm multiplying that by itself, 28, and then minus x. 28 times 28 is 784. 28 times negative x is negative 28x. 28 times negative x, again, negative 28x. Negative x times negative x, negative times a negative is a positive, x times x is x squared. So I'm going to replace this in parentheses with the inside of my box. So I have an x squared. Let's combine these terms. Negative 28x plus negative 28x is negative 56x. And then plus 784. 20 squared is 400. Combine any like terms that I have. I notice I have 2x squares minus 56x plus 784 gives me 400. All right, this is the moment where I stop and look and I see, okay, I have a quadratic, so I'm going to need to solve this quadratic. To solve any quadratic, it needs to be equal to 0. It's not, so I need to make it equal to 0. Subtract 400 from both sides. Okay, I have 2x squared minus 56x plus 384 equals 0. I have a quadratic, it's set equal to 0, so now I can solve. My options for solving, I'm going to erase this so we have room. My options for solving is I could factor, I could complete the square, or I could use the quadratic formula. Because the coefficient of x squared is bigger than 1, I'm going to go ahead and use the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4 times a times c, and everything over 2 times a. Okay, in this case, a is 2, b is negative 56, and c is 384. A, b, c. So then I'm just going to plug these numbers in. The opposite of b, so the opposite of negative 56, plus, and I can only do one of these operations at a time, square root of, I'm going to put my b in parentheses. Anytime you plug a number in, put it in parentheses. It's important because since this is a negative, if I did not have it in parentheses, I would have the wrong answer. I want to square negative 56, so it needs to be in parentheses. So negative 56 squared minus 4 times a times c, which is 384. All of that over 2 times a. And if I was to plug that into my calculator, I would end up with x equals 16. Okay, so here I have my triangle. Let's redraw the triangle quickly. That was 20, this was x, and remember this was 28 minus x. Well, I now know that x is 16, so how am I going to figure out the length of the other leg? I will do 28 minus 16, which is 12. So one leg is 16 centimeters, the other leg is 12 centimeters. Alright, so those are some examples of the Pythagorean theorem. You're going to be applying these in class, so make sure you know this and you absolutely know the important thing that C is always the hypotenuse. Alright, I'll see you tomorrow.